Welcome. Hello, Namaskara. Yes, this is your captain Shreyas, your physics master teacher on the Vedantu JEE English channel, and we are on to Newton's laws of motion. And today, in lecture number 2, we are going to focus mainly on friction, blocks on blocks, and angle of repose, and also all the friction related questions in Newton's laws. In the previous lecture, we have seen tension, we have seen block questions, pulley mass systems, drawing free body diagrams, and also the standard applications of all the three laws, which we have studied in beautifully detailed manner, right? So it's time to begin the class. And if you have not yet marked your attendance, smash that like button. And also, if you are new to the channel and you don't want to miss any of the cool updates, academic classes, and all the important tips, strategies for your JEE preparation, make sure you are subscribing. Welcome all the JEE 26 and 2027 students. Hi Maha, hi Harshit, hi Nikita, hi Abhi. Welcome Pritika. Nice to see all of you. Ipide irukunga. Yes. Hello Harshit. Welcome. Ellaru hegidare. All right. Welcome. Good evening. Good evening, William. Awesome. Awesome. Sir Vedantu gives me really good offers, of course, for all of you. And by the way, I hope you know there is MVSAT which is coming up very soon, which is the Mega Vedantu Scholarship Admission Test. It's a good test to judge where you stand in the real competition for all class 8th, 9th, 10th, 11th, 12th dropper students, JEE, NEET, everything. So make sure you're registering for the MVSAT examination. Not only you will know where you stand, because there are 2 lakh, 3 lakh kids who are going to give this. You are going to get a lot of goodies, resources, brochures, counseling material, everything. And if you do well, of course, you are going to get prizes worth, crazy amounts, crores of rupees. But there is a pool, and we are going to give you all those amazing gifts and hampers and prizes. And of course, scholarship exam is meant for giving you scholarship. So you will get amazing discounts on all our batches and courses. So make sure you are participating by registering with the link in the description box. It's from 4th October, 5th October, 11th and 12th of October, offline mode. Online, you need to fill in the form so that we can make a request if you want it online. But the best experience is offline because you get to meet all the amazing teachers. All your favorite ones will be there and on these dates, right? So it's time to begin the class of friction. Welcome aboard. Nice to see you. Hello, Rama. Welcome back. Oh, right. Welcome, Pritika Surya. Hi, everyone. Great. Yes, IIT Hyderabad is good. Definitely. It's a great institute, man. Many people even drop out of IIT sometimes to take triple IT because they want computer science IT fields, right? So it's a definitely great institute. Okay. Hi, Hi, Venkata. Welcome aboard to the Vedantu JEE English channel. Now, if you remember in the previous lecture, I have mentioned something about contact force, but just to give you a brief round of about that. If you have any two surfaces in contact, okay, so maybe I have this particular surface and maybe this particular surface in contact. So you will see there is some kind of contact force between them, and the contact force can be at any angle. The contact force can be at any angle. Let's say the force is in this direction. This contact force, this contact force is purely electromagnetic in nature. It is electromagnetic force between the surfaces. So that is what you call as the contact force. And if you remember carefully, I have also mentioned that if you draw perpendicular to that surface and you find the component along it and you draw a parallel line and you find the component along that parallel line, this perpendicular is called normal. This parallel is then called friction. So this is your frictional force. This is your frictional force, and this is then your normal force of action. Normal means it has to be perpendicular to the surfaces. Is that right, everybody? Till this point, absolutely clear? Of course, the contact force vector wise can be split into normal and friction, parallel and perpendicular. Magnitude wise, you can just say using Pythagoras, it is n square plus f square, the whole thing under the root. This is f square plus n square, whole thing under the root is the hypotenuse. You can just slide it over here. You can see a beautiful right angle triangle. Everybody fine till this point? Give me a thumbs up quickly in the chat box. Yeah. Hello, welcome Srihari. Welcome all the new students. I'm pretty sure William, you will do wonderfully in the Sigma Express batch. Hi Surya. Hi Tilak. Good evening. Good evening. Good evening. Now that we understand contact force is electromagnetic in nature, it just comes because two things are just touching with respect to each other. When they are not touching, contact force is not there. And that contact force will be at some angle. It depends, whatever angle it could be. Depends on the friction values and normal values, etc. You also have a term over here, which is the angle made with the contact and the normal. So that angle I will call it lambda. If lambda is more, then contact force is here. If lambda is less, contact force is here. So if lambda is more, then the friction is higher. If lambda is less, the component of friction is less. So lambda indirectly gives me an idea about the friction, the angle between normal and contact force. That is why it is also known as the angle of friction. It is also known as the angle of friction. For a constant normal force, if lambda is more, friction is more. If lambda is less, friction is also going to be less. And you can see that if you shift frictional force over here, it's a standard triangle. I mean, if you want, I can just redraw it for all of you. This would be the triangle, guys. This would be your contact force. Of course, this will be normal and this would have been friction, right? That is how it would be. Yeah. So this is 90 degrees. So angle between normal and contact, right? This particular angle was lambda. So if you think carefully, you will realize that this is basically your lambda. If this is lambda, parallel lines intercept. So this is also going to be a lambda, right? These are two parallel lines and this is an intercept. So if this is lambda, obviously this is also going to be a lambda. So you can see lambda trigonometrically can be said tan of lambda is f by n, sine lambda, cos lambda, whatever you want, you can find it out. So for example, if I want to find tan of lambda opposite by adjacent, it will be the frictional force divided by the normal force. So you can find out how much is the angle of friction if you know friction and normal, or if you know friction and contact, anything. You can use basic trigonometry formula. Everybody fine till this point? Yeah, what is the angle of friction? So if lambda is more, tan lambda is more, friction is also more. If lambda is less, friction is also less. Direct, you can see relationship between them. Good evening, Incorporated, welcome aboard. Okay. Yes, Abhiram, you can definitely ask me and maybe you can put it up in the comments. That will be better. Naveen, good evening. Good evening. Nice to see all of you. Yes, Rama, got it. Everyone. Srihari, Kabilan, got it. Vetri, Supriya, Tilak, Abhiram, Siva. Yep. Relative velocity already done. I think you guys missed the class of relative velocity. In case you have missed the class of relative velocity, it's just in the video section. It's not in the live. I had put the actual recording of our Sigma batch, so you can definitely check it out. It should be there in the playlist if I am not wrong. Oh, it is not added in the playlist. I will add it in the playlist. My bad, because it went to the video section. It's right over here. Okay. Where did it go? Where did it go? Somewhere it is. Yeah, this one. Relative motion. 4.5 hours I have taught it, like insane amount. Yeah, I mean this much detailed class, I don't think you'll get it on YouTube. Okay, so please check it out. Relative motion 1D and 2D. Okay, in case you have missed it, right? Good evening, Ashwin. Yeah, others clear. All right. Okay. If you are in V Prime course, to avail that Eklavya discount, you join the Eklavya batch, share the details of your V Prime with your mentor in Ekalavya, with the academic mentor, or that's it, and that amount will be refunded. It's very simple. So after you join, you need to give a proof of enrollment in V Prime, any batch, and then you will get it back. Got it? Okay. Yes. Yes, Nishal, that is enough for your preparation. Definitely. Now let's focus more on the word of friction. And when we talk about the word friction, people think it's a bad thing in life, but not really. Friction can be good, can be bad, depending on where you apply it. Like for example, I am able to hold this pen because there is friction. If I saw a world without friction, then this pen would never be in my hand. This would have slipped out of my hand. How am I able to hold it? Because of friction, right? Same way, imagine I won't be able to walk because I get a grip because of friction. My car, bike, cycle, nothing will work. I will not be able to turn my cycle or bike or car because the grip is what enables a car, bus, truck, vehicle to move forward, brake, everything to turn, etc. But friction is also bad at times. I mean, like if something is set in motion, the wheels are rotating, then the surfaces are getting rubbed, and because of this rubbing action, you're wasting some amount of energy against the friction in terms of heat and other losses. So there are a lot of losses which occur because of friction, and you could have saved a lot of energy. I mean, our engines, motors, everything could have been more efficient then. But obviously there are some good things and bad things in life, so you have to take it the way it is. So friction causes a lot of loss of energy. In many cases it can be minimized by lubrication, so that's why you add oils. So you would have noticed, if some oil, even your cooking oil, spills on the floor, you would have slipped on that floor. Have you witnessed that? So same way, if you put oil in moving parts or grease, then it lowers the friction, it makes it smoother, and it becomes efficient till an extent, not 100%, nothing is 100%. So you can reduce the losses, but you can't eliminate it really. Okay, so a lot of times whenever there is rubbing action, etc., you will see friction is there. Friction is like the grip. It enables us to hold things and walk on things, and helps the automobiles turn and accelerate and decelerate. Yeah, definitely clips. It is useful for mains 2026. Definitely. Yeah, it's a necessary evil. Very rightly put, Adarsh. Now, I will put some important points regarding friction. So, friction opposes opposes the motion or its tendency to move. It's rightly said. I would have put this anyways. It's a necessary evil. Okay, it's necessary at certain times but bad at certain times. Okay, you will hear about this in the another chapter, which is called work power energy. It's a non-conservative force. It's a non-conservative force in nature. It's a non-conservative force in nature. Just to give you an idea, non-conservative means whenever such forces are there, then energy is not conserved. Okay, mechanical energy, which is a separate concept in a chapter of work power energy, you will see mechanical energy will not be conserved whenever friction, these evil forces are there. We'll talk about it later on. For now, just remember it is non-conservative. The word comes because it does not enable the energy, mechanical energy, to be conserved. All right, great. Now, this friction is of two types. There are basically multiple types of friction. One is your static friction, another one is your kinetic friction, and slowly you will learn in the chapter of rotational motion, rolling friction. Rolling friction. For now, let's not focus our attention on rolling. Let's only focus on static and kinetic friction, because this will be dealt separately in rotational motion. You will not get any problems as of now. So let's understand the different types of friction, static and kinetic, for now. Okay, let's understand static and kinetic friction for now, because this is what you will see mainly in this chapter. Okay, kinetic or dynamic, both are same. It's perfectly fine. Let's start talking about static friction first, and then let's talk about kinetic friction. For that, I will open up our FET and you will realize everything immediately. Okay, static friction and kinetic friction, the best thing to open up is our FET and you will start realizing things very easily. So motion, okay, and let's get friction into play. Okay, great. As you can see, this surface is having friction. See, if it did not have friction, this dude out here, if he pushes this block, it starts moving. Let's see the values and the speed. So it's very obvious. So the speed begins to increase because it's perfectly smooth the moment you apply any force. The moment you release the force, no force is there. By Newton's first law of motion, the box continues its state of rest or motion. As you can see, the speed is maintained. It is no longer accelerating. But the moment I put some friction, you can see it starts decelerating, the speed reduces and it stops. Wow, that's what friction does. But now, did you realize there are actually two kinds of friction? And I'll show you how. Imagine this. Now, this dude comes over here, is applying 1 Newton of force. Is the box moving? No. So if it is not moving, the forces are balanced. So if you apply a Newton of force, it should be balanced by a Newton. But who is giving that Newton? That is friction. Oh, that friction is trying to oppose, because think of the surfaces which are touching. There are a lot of cracks, gaps and valleys and hills and all of that. So, there is locking which is happening between those two surfaces. No matter how much you polish, you cannot get rid of those interlocks. Even the world's best smoothing machine cannot remove, because at the molecular level, it's a lot of valleys and peaks. Now it's interlocked. You apply 2 Newton, it's not moving. The only conclusion is that friction is also 2 Newton, because only then Newton's first law says it is at rest, it is at equilibrium. That means forces are balanced. Oh, so I can see as I apply more and more force, friction is also increasing. Oh, this is crazy, sir. Let me apply more force, more force. Even 20 Newton, nothing is happening. Guys, the surfaces are not sliding. Now you only think and tell me, is this stationary kind of friction or kinetic, which is dynamic or motional kind of friction? The surfaces are not moving, they are at rest. So this friction which is coming into play is static in nature. It is static in nature because there is no relative motion between the surfaces. It tries to move, yes, there is a tendency to move, but there is no actual motion. What do I mean by tendency? Tendency means if you remove the friction, it starts to move. It wants to move. You're stopping it from moving because you have applied friction. That's it. Or there is roughness between them. It has a tendency. Okay, like you have a tendency maybe to go out of the class, but your teacher or the class monitor is stopping you from going out. Makes sense, right? The moment the monitor or the teacher is not there, everybody is out. So they begin to move. So that is tendency, where you want, but you don't do it. Okay, I keep increasing. Sir, as I can see, as you are increasing the force, friction is also increasing. What does this tell you about the word static friction? I increase the force, friction is like, I will also increase. Oh, sir, what if I decrease the force? Friction is also decreasing. It's not staying there. So it clearly tells static friction adjusts itself as per the external factors to try its best to keep the surfaces at rest. It's adjusting, right? It's self-adjusting in nature. You apply 10, I apply 10. You apply 20, I will apply 20. Wow! Sir, static friction is so cool. It adjusts for us. It is adjusting for us. But like in life, everything has some patience level. Pavam, this friction is adjusting. I am saying I will apply 58, friction is also, I am like 58. You apply 61, friction is also like, okay, I will be 61. I think there is always a limit to everything. When that patience is done, I mean, you lose your cool, like, boss, I'm not going to stop it. Yeah. So there will be a limit to it. That means there will be a limiting friction also. Oh, so what is the limit exactly? Can we test it? Of course, let's test it. Slowly, I'm going to increase. I'm making it angry. It's becoming very furious now. The moment you see the speed increasing, that means the limit is crossed. Okay. Keep an eye on the speed. So the moment the speed increases, That means the limit has been overcome. 96 Newton also nothing is happening. Whoa, crazy, sir. This is amazing. 110 also nothing is happening. 115 also nothing is happening. Oh, it started moving around 124 Newton. Oh, let me remove it again. Let me remove it again and see what happens exactly. Okay, second. Okay, it stopped. Okay, 111, nothing is happening. 114, nothing is happening. 115, 17, 18, 19, 20, 21, 122, nothing. 123, it begins to move. So the limit is 122. Got it? Limit is 122. After 122, friction lost its cool. But I think it will be different if I used maybe some other object. Let's say I use a fridge. The surfaces are different, no? So I think it will be different. I mean, the coolness might be lost at some other Newton. See this fridge, even at 150 Newton, it's like, boss, I'm staying there. It's not moving. So I think that limit of friction also depends on the nature of the surfaces in contact. I don't know how much it will be. Even, oh my God, 200 Newton also it is not moving. 250 also not moving. 300, 350. Will it even move? 450. Oh my God. It was really rough, huh? Somewhere between 450 and 500 was its limiting value. After 500, it became, after some number between 450 and 500, it began to move. Isn't it crazy, guys? Are you now feeling the limiting friction, static friction? Oh, great. Sir, but there is an issue. Once it started moving, once there is actual motion, what kind of friction will be there? There is no more interlocking which is stuck. It's now sliding over those roughnesses, over those cracks, over those, peaks and valleys. Yes. Now the friction is kinetic in nature. Now if I remove the force also, look at it, even if I remove the force, still friction is there. Why? Because the surfaces are moving relative to each other. This friction in motion is called kinetic friction. Can you see that? This friction in basically motion is then called kinetic friction. Let's get back our box. And I remember somewhere around 123, the friction was, 123 force onwards, it starts moving. So 122 was the limiting value. Now keep this number in mind, 122 Newton. Okay. Now I increase to 123 and look at the friction. It suddenly dropped down to 92 Newton when under kinetic mode. My applied force is 123, but when in motion, the kinetic friction is not 122. It's not staying the same. It suddenly dropped down, if you realized. Sir, if I apply even more force, what will happen? Nothing will happen, boss. I mean, just see. Even if I reduce the force, this friction is constant. So this is very much different, very much different, very much different than static friction. No matter what you do, the kinetic friction is constant. So it is not self-adjusting. It's a constant force for the same surface, right? And it acts until it is moving. Look at it. The moment the speed reaches zero, the friction will disappear. Gone. So as long as they move, friction is there. The moment they are not moving, it will either come back to static mode or it will just disappear if there is no tendency. Yeah. Is that right? Everybody loved this? Are you getting a complete understanding of how static and kinetic friction works? So let's write down the notes over here. Starting off with static friction first and then kinetic friction. So static friction always opposes the tendency of motion, opposes the tendency of motion. That's the number one thing. Second thing, it is self-adjusting in nature. It's self-adjusting in nature. It's self-adjusting in nature. Okay. Another thing which I could not show it in the demo, but it is true. It is independent of the area of contact. It's not like small area versus big area, more friction, less friction, nothing like that. It's independent of area. Independent of area. There is a limit to the friction, to the adjusting nature, limit to the max value of maximum friction which can be tolerated. Sometimes this is also called as Fs max. And static friction, the symbol for that usually is Fs. Usually is Fs. Usually it is Fs. S stands for static, S stands for static, F stands for friction. Since I mentioned it is self-adjusting, it also means that if you consider the Fs value, it is less than or equal to Fs max, and it will be more than or equal to 0. Okay, so the friction can lie anywhere between 0 and Fs max. Those are the extremities. It will adjust itself to keep the surfaces at rest. Beyond Fs max, it can't tolerate, it will go into kinetic zone. Okay, these are some basic pointers which you should know about static friction. If you talk about kinetic friction, it actually opposes relative motion. It actually opposes relative motion. Number one thing. Second thing, it is not adjusting, rather it's a constant force as long as they move. They means the surfaces. As long as they move, it is a constant force. Next thing, the symbol for kinetic friction, it's basically Fk. As you can see, it is basically Fk. Okay. Here there is no limit, and also it is independent of the area. That is standard. Even if area is big or small, it doesn't really affect. So it is independent of area of contact. Independent of the area of contact. One thing though, the kinetic friction is always going to be less than your maximum limiting friction. It is always going to be less than the maximum limiting value of the friction. And it can be also seen in one beautiful graph which I'm just going to draw over here. Imagine somebody decides to pull or push something, pulling or pushing something, and on this side we plot friction, y-axis. I'm plotting friction. If you apply some pull or some push, the friction will proportionately increase. The friction will proportionately increase till a limit. By the way, this is right now static in nature because it is adjusting. You pull more, friction will increase. Pull more, friction will increase. Pull more, friction will increase. But there is a limit till which it will increase. So that limit, remember, will be Fs max. Limiting friction. Maximum static friction, whatever you want to call. After that, the value of the friction will fall and it will be constant. It will not change then, irrespective of the speed or whatever. It will fall down. Okay, it will fall down abruptly and it will stay at Fk. This particular value that you are seeing, this will be Fk. And Fk is lesser than Fs max. Keep that in mind. Sudden drop. I just showed it to you right over here. Once it begins to move, that's it. It's gone. The friction will drop down to a lower value. Instead of 122, it will become 92. Why is that case? Because, can you guess? Why is it that the friction is reducing once in motion? I mean, you would have experienced it by nature and by experience of pushing some furniture. To start, to initiate, it's difficult, but once it is moving, it is easier. And it's also true for studies. To start studying is difficult, but once you begin studies, you go in the rhythm and flow. Because once the objects were at rest, the gaps are interlocked. It's tight. But once you move it, that interlocking is broken. It will not get enough time to again interlock the surfaces. So it's easier to keep it moving. So keep in mind that this statement means it's easier to keep it moving, and it is difficult to get the surfaces in motion, because that is decided by Fs max how difficult it is. But once it is in motion, how much I need to apply to keep it moving, it's always lesser. Okay, so that is why Fk is less than Fs max. Clear? Understood? Clear? Everybody with me? Yes. Hi Ketan. Yep. Perfect. Amazing. Now, let's also understand how much is the value of the static friction and the kinetic friction. That's going to come on the next slides. So for that, let me do a simple experiment. Okay, I'll keep the friction a little bit less now. Okay, so that it will be easier to move it. So at 100 Newton, it begins to move very easily. So let me get it back to stop. Okay, 50 Newton, I'll just try to figure out at what Newton is it moving and I will note it down. So look at the speedometer. Once it begins to move, that means, I have overcome the friction. 66, yes. So 65 Newton was the limit. Okay, those of you missed it, I'll show it again. Look at it. This was, sorry, yeah, 65 Newton not moving. 66 Newton began to move. So 65 Newton was the limit. Okay. Now what I will do? Now observe what I will do. Okay. I will stop it. It's not yet moving. I'll keep exactly one more box on it. Now tell me, will that limiting friction change or not? Answer it in the chat box. Will that limiting friction change? Yes or no? Okay. Think carefully. Sir, the surfaces are the same. So why will limiting friction change? Because you just told it depends on the surface. It's the same wood, same cement, whatever. Sir, so limiting friction should not change. Yeah, okay, but I have an issue. If I add more weight on it, basically the contact force will increase. Reason, earlier there was one block. So there was maybe this much interlocking. But the moment you add one more block, there will be more interlocking. You add one more block, more interlocking. Because now the surfaces are pressed. It's very difficult for this interlocking to break. So I have a feeling it will not move at 66 Newton. You want to try? Okay, 65 Newton, not moving, of course. 66, it's not moving. Any guesses at what Newton it should start moving? Just take a rough guess. Two blocks, double the effort will be needed. Makes sense. So 65 to 2, 130. So close to 130, 131. After that, it will start to move. So let's try it out. 116 not moving. Okay, so let's see. 123 not yet moving, guys. Yeah, normal force has increased. The contact between the two of them has increased. 126, 127, 128, 129, 130. 130 not yet moving. Remember, 65 was not moving. 66 it began to move. 130, yes, perfect. Exactly what we expected it. So this clearly tells that the limiting friction not only depends on the surfaces, but also the normal force between them. More normal, more contact, more interlocking, more difficult. And it's also true for the contact force. For the frictional force, my bad, of kinetic. Look at it, the kinetic friction right now is 97 Newton. The kinetic friction is 97 Newton. Let's get rid of this block. You can see it becomes 49 Newton, almost like half. You increase the normal, kinetic friction increases. You add more weight, it will increase even more. So clearly, it is obvious that the kinetic friction also depends on the normal force. Is that right? Everybody with me on this? Okay, perfect. Perfect. So let us write all these things down in the next slide. So I'll just put it up over here. So the value of Fs max, the limiting friction, is directly proportional to the normal force. So say for example, this is our surface which is in contact with another surface, and we say that there is a normal force over here, and maybe there is a tendency to move. Maybe there is a tendency to move. This is how the tendency is. That means it wants to move there. So static friction will always oppose that tendency. So static friction will act like this. This is how your static friction will be. And as you push more, Fs will increase till that limit, which will now be Fs max. That's how it will be. Eventually, that Fs will reach Fs max. Okay, I want to get rid of that proportionality. So therefore, I can just say Fs max is a constant mu s multiplied by n. Now, this constant which you are seeing over here, that is basically called as the coefficient of static friction. Coefficient of static friction, and this particular coefficient of static friction completely depends, it depends on the nature of surface, nature of the surfaces, nature of the surfaces. Wood, marble and stone, cement and rubber, it will be all different. That mu will change values. It could be like 0 0.6, 0 0.7, 0 0.8, 0 0.1, 2.1, 3.2, 1.7, like that. These are the rough values of the ranges of the friction, coefficient of friction. Yeah, coefficient of static friction. It's a dimensionless number. Yes, it is. Please keep in mind, it is, of course, dimensionless. It is a dimensionless, unitless number. Okay, and if at all mu s is completely zero, then it is very, very smooth. There is no frictionless at all, or basically frictionless. But if mu is more, then I would say it is rough. I would say it is rough. Like if mu is 0.7 versus 0.3, 0.7 means more rough is there, more roughness is there. 0.3 means it is not that rough, it is relatively smoother. That is how you interpret the value of static friction coefficient. Cool? Okay. What are the factors on which the coefficient of static friction depends on both the things, the normal and the nature of the surface. So the actual value of the friction depends on the normal force and also the nature of the surface. If I change the nature of the surface, see, friction will change. If I change the nature of the surface, friction will change. It also depends on how much normal I am putting. More normal, I can see obviously friction will also change. But coefficient only depends on the nature, not on the normal. It's the property which is dependent only on what kind of surfaces are in contact. Is that absolutely clear? If it is equal to 1, nothing will happen. It can be more than 1, like rubber and cement, it's around the range of 2 and 3, 2.4, 2.5, like that. Glass and glass has a coefficient of friction more than 1. So there is no rule that coefficient of friction has to be less than 1. I don't see any problem with that. There are many questions where mu is more than 1, and you can see a chart of table online, internet, anywhere. See, a lot of things are there where mu is more than 1. So it is just a notion which is in our head. We feel that, oh sir, it is always a ratio less than 1, wrong. Nothing like that. It usually is less than 1, but if it is more than 1, that means it is very badly rough. It's like crazily rough. That's all. It's so very, very rough. That's all. Yeah. The maximum value of static friction is called limiting friction. Yes, you can also call it Fs max. Limiting friction, maximum static friction. Yeah, all that are the same things. Is that okay, Dilip? Perfecto. Amazing. Nobody is going to give you the theory like this, the way I teach you, with such amazing simulations. I can guarantee you that. Especially for all the South Indian students, this is like the boon channel. So, my dear warriors, please make sure you're subscribing. You're telling your friends, whether it is from Andhra, whether it is from Telangana, whether it is from Karnataka, whether it's from Kerala, whether it's from Maharashtra, whether it's from Tamil Nadu, whether you are from UAE or, maybe Northeast, because a lot of kids love to watch English classes. This is the best content, not just in English, in fact, many Hindi channels too. Right. Great. Amazing. So let's move to kinetic friction. What is the formula for that? Same formula, guys, again over here. So imagine there is this surface which is in contact with this surface, and this is actually moving. There is actual motion which is happening like this. So this is again the normal force. The friction will obviously oppose that normal force, And you will again say over here that the kinetic friction is directly proportional to the normal, and the value of the kinetic friction, forgetting the constant of proportionality, will be mu k multiplied by n, where this mu k is nothing but the coefficient of kinetic friction. Coefficient of kinetic friction. It is also dimensionless in nature, and of course it only depends on the nature. It depends on the nature of the surfaces in contact. Nature of the surfaces in contact. Perfect. It is also dimensionless entity. Okay, so keep all these things in mind. All right. Now, same thing, just like if mu is more, friction is more, mu is less, friction is less. I had also mentioned that, where is it? Over here. Yes, Fk is less than Fs max. Fk is usually less than Fs max. So what can you tell of the relation between mu k and mu s? Mu k and mu s? Yes, mu k will be less than mu s usually. Mu k will be less than mu s, yes, as a general rule of thumb. But usually how the values of mu k and mu s are, I'll tell you, give an example. For example, mu k is 0.732, then mu s will be 0.737. Like that. That's how much different they are. They are very close, but a small gap difference will be there. So usually what happens for most of the practical purposes, so usually what we do, even though it is less than a relationship, we say mu k is roughly equal to mu s, and we give them a common symbol and we just call it mu. As simple as that. Because the difference is usually in the second, third, fourth, fifth decimal places, not so much of a difference for most practical calculations. So that is why we just give it a symbol called as mu. Okay. Faizad, the classes in the Sigma Express batch starting I think 20 or 21st of August. It's there in the link of the description box. You can just check it out, open it right over here, man. Yeah, just go to the live class, go to the session right over here, and just say Sigma batch right over here, and you will see Sigma Express, and the batch is starting 20th of August. Okay, fair enough. Yep, perfect. From another chapter, but we will solve another chapter's doubts later on. We can't interfere with other chapters. Dilip, put it up in the comments, not now. Okay, focus on the lecture. We'll not go against the flow of the lecture. Okay. Now, having said this, let us start solving some questions, my dear. Okay, let's start solving some questions. Here is the first question coming up on your screen. Imagine there is a box of 5 kgs and it is given to me that mu s is 0.6 and mu k is basically 0.4. Question is find number 1, the minimum horizontal force to set it into motion. The second thing, the force needed to keep it moving, once set in motion. Number 3, very interesting. If the force of whatever answer I find in 1 is applied when in motion, then can you figure out the acceleration? Very interesting question. Let's try to draw the diagram. Let's try to figure out one by one. Okay, erase this. I'll keep the question slide separately. Okay, let's draw the diagram. Let's think of the block first. So right over here. Okay, our surface is also right over here. Okay, this is the surface. Okay, so a block of 5 kg, mu s mu k given, minimum force to set it into motion, force needed to keep it moving, and force if you find it in one, the same force if you apply once it is already moving, then what will be the acceleration? Okay, let's try to figure it out. First of all, if you think about the forces acting on it, one will be the weight of it. It's a 5 kg block, so m into g. Then there will be a normal force like this, and that normal force will be exactly equal to the weight, which will be 5g. G value is 10, so it will be nothing but 50 in numbers, 50 newtons. Now you have to push it or pull it, and you are applying that external force F. It will be balanced by the static friction. If you just want to set it in motion, okay, if you just want to set it in motion, so that minimum force which will be needed, so I'm trying to figure out the first answer, the minimum force will be needed will be the maximum friction which it can resist. So that bare minimum force which will be needed to move it, just move it, will be when the friction has reached its maximum capacity. Is that making sense? And the maximum capacity of friction, we all know, is mu s multiplied by n. Mu s value is 0.6. Normal value is 50. 6 5s are 30. Decimal and the 0 gets swallowed. So it will be 30 Newton. So this is the bare minimum force needed to just move it. So 31 Newton, 32 Newton, everything. Okay, it will start moving. So 30 Newton, 30.001 also it will move. Till 30 it can hold. So beyond anything beyond 30, it will start to move. Yeah. Now let's go to the second part. Once it is already set in motion, so it has some velocity. So now this will no longer be Fs. This will be obviously Fk. This will be obviously Fk. So for the second part, as you can see, to keep it moving, obviously it is kinetic in nature, and since there is no acceleration, okay, no acceleration because velocity is there, so our force will be balanced by Fk. Mass is 5 into acceleration. Force minus Fk is mass into acceleration. Net force is ma. So therefore F will be Fk. Therefore, F will be, Fk is nothing but mu k into the normal. What is the kinetic friction? It is 0.4. Normal is 50. 5 4s are 20. 0 and decimal swallowed. So 20 Newton. As you can see, my maximum limiting force was 30 Newton. But the moment it entered kinetic zone, it is 20 Newton. So 20 Newton is the kinetic friction. 20 Newton is the kinetic friction. Very good. Many of you got it. Don't give the answer as 31. No, no, no. Dilip, 30.001 also it will move. So what will you write the minimum force as? You can't say 31 because between 30 and 31 so many infinite numbers are there. So then will you say 30.001? No, even 30.0000001 also it will move. Okay, so for that cases we say minimum force is 30. It's understood that exactly at 30 it will not move. Any small twinge difference also is there. One chintu mintu difference is also there. It will begin to. Okay, so don't say 31. That will give you a wrong answer. Okay, modern physics will come very late, Swami. Okay, it's quite the last topic if you ask me. Now the third answer is very interesting because then it is accelerating. F minus Fk is mass multiplied by acceleration, Newton's law. If the answer which I got it in the first one, what is the first answer? 30 Newton. So if I put F as 30, kinetic friction is just this value, which is 20. Mass is 5 multiplied by A. So therefore, 10 is equal to 5A. Therefore, acceleration 10 by 5 is 2 meters per second square. So if you apply the same force as the static friction, maximum value, remember, it will be more than what is needed to keep it moving. You just need 20 Newton, but you are giving 30 Newton. So the difference of it will accelerate it by 2 meters per second square. Excellent. Not meters per second, meters per second square. Correct. Perfect. Let's go to the next question on your screen. Here it is. Coming up. Okay, 1 second. Yeah. The next question as follows. Observe carefully. Okay, I'm drawing the diagram. I'm just drawing the diagram for you. This is how it is. Okay, and this is the surface. Okay, and I am just applying a force over here. Let's say F. Okay, let's say F, and and imagine it is also told to me this is example 10 kg. This is example 10 kg, and let us just say this is 37 degrees. This is 37 degrees, and let's say this force which you have applied, okay, it is maybe, I don't know, maybe 100 Newton or maybe 50 Newton, anything like that. Okay, let's say it is 100 Newton. Let's say it is 100 Newton. Okay, and it is known to me that it is moving with a constant velocity. I just know that right now the velocity is constant. The question is, can you find the coefficient of kinetic friction? Can you find the value of kinetic friction in this particular question? Can you find how much is the kinetic friction if it is moving with constant velocity? I think we should draw the free body diagram. Okay. In the free body diagram, I will realize because velocity is constant, that means how much is the acceleration? Quickly answer it in the chat box. Constant velocity means? Yep. Sir, did you revise 11 syllabus means? Slightly greater than 30, greater than. Okay. Even I did not find modern physics previous lectures done by you. I think it is there. It is there. Just check Flash Express, Flash 2.0, Flash 1.0, or some Flash. It should be there. Modern physics I have done. Also check my very old classes, Nurture and Pathfinder. Find it in Pathfinder. Pathfinder was for 12th, Nurture was for 11th. You will find it in Pathfinder playlist. Okay. Acceleration will be 0. Perfecto. Excelente. Sir, will the syllabus be over by October or November? The syllabus will be over by October for class 12th. Okay, we are not going to extend it beyond October. For class 11th, it might go till November, but we'll try to finish it by October only. Okay, cool. Yeah, in Sigma batch, it will be both 11th and 12th, and it's not revision of 11th, it is teaching of 11th and 12th. Okay, both 11th and 12th are being taught, but whatever you have missed, that will be taught live in one shot after October, November. Okay, I hope I have made it very clear, Faiz. Now, I will complete the free body diagram, but before that, I feel I should resolve this force. I don't like this. I don't like this. 100 Newton. I want to get rid of this 100 Newton. So I think there will be one component which will be like this, and there will be other component which will be like this. How much will be the horizontal? It will be 100 cos 37. Now cos 37, as you can remember, yes, cos of 37 will be 4 by 5. So therefore 100 by 5 is 20, 20 into 4, that is 80 Newton. And over here, similarly, this will be 100 sine 37. Sine 37 is 3 by 5. So I think it's going to be 60 Newton. So 60 Newton and 80 Newton, we can get rid of this 100 Newton. But of course, there are more forces over here. That 10 kg force is there. So 100 Newton weight is there. And do not forget the normal force. A lot of people I've seen, they will forget the normal force over here. So do not forget the normal force also. So there is N, normal reaction, NR I will put it. And of course, there is frictional force. A lot of people forget the main thing, which is friction. So Fk is also going to oppose the motion. Okay, sir, perfecto. Now what? Now what, guys? Okay, let's do one thing. Because acceleration is 0, all the forces should be balanced. So 80 Newton and Fk should be balanced with respect to each other. So if you ask me in the x direction, Fk will balance the forward force, which is 80 Newton. That's it. Those are the only two forces. Fk is mu k into n, so that is equal to 80, and mu k is what I do not know. Lot of you are going to say the normal force is 100, but that is exactly wrong. Okay, right? Think about it. Adventure, it will be there. Just check in the extra content or something. There is a sheet full of recordings, but if it is still not there, just message me privately on Captain Shreyas Instagram, Telegram with the screenshot. I will get it resolved, or basically call VCare, Vedantu Care. They will get it resolved. Okay, it is there. Previous recording, it's there in a sheet. All right. So what you do is you check the Y component. 60 and normal both are upwards. 60 and normal both are upwards. That will balance the downward, which is 100. So therefore, technically speaking, the normal reaction is 100 minus 60, which is 40 Newton. So this normal reaction is faulty, and it is not the weight, because a part of our force is helping relieve the normal. It is supporting, it is assisting it. So normal is not that much. It is a little bit less. It is 40. And this is of course 80 Newton. And as you can see that the kinetic friction is 80 by 40, which is 2, which is more than 1, which is okay with me. Don't get shocked and think, sir, maybe I made a mistake. Maybe it should be 1 by 2. Don't say that. It is 2. It is very rough. That's okay. Yeah. So the catch over here is the normal, which is not the usual mg over here. All right. So let's think of another question coming up on your screen, and here it comes. Imagine it's told that there is a box of 20 kg moving at 10 meters per second on a surface whose roughness is 0.2. Question is, find the distance, or let's say find the time after which it stops. Find the time. You can also find distance later on. Find the time after which it stops. So how much time does it take stop? That is the question. All right. So let's think carefully. Let's draw the block. This is the block. This is our surface. The block is in motion. It keeps moving, and eventually it stops. In this duration, it's very obvious that because the velocity is that way and it is stopping, it is decelerating strictly. So there is a deceleration in this direction. Yes, it is essentially decelerating. So acceleration is here. Acceleration is opposite to the velocity. Opposite to the velocity. Other forces acting on the block, normal, okay, mg, and of course friction, nothing else is there. Mass is 20, or I will just put mg for now. There is normal over here and there is friction over here. These are the only forces. So this force is causing this acceleration, if you ask me. The force is causing that deceleration or acceleration. Nihal, so final velocity is 0. Yes, perfect. Now, if you ask me in the x direction, the only force is Fk. So Fk is the mass times acceleration. Friction is kinetic friction into the normal, that is ma. But how much is the normal? Normal is equal to mg. So mu k into mg is equal to ma. Perfect. Now mm cancels. Therefore, acceleration is mu k multiplied by g. Oh, nice. Acceleration is mu k multiplied by g. Amazing. What do I do with the acceleration? Use it in kinematics equation. I know we have to find the time. So final velocity is initial velocity plus acceleration multiplied by time. Finally, it stops. Initially 10. Acceleration is negative mu k into g, and we have to figure out the time. So bring it on this side. So mu k into g into t is equal to 10. Therefore, the time is 10 divided by mu k is 0.2 and g is 10. 10 cancels. So 1 by 0.2. 0.2 is 1 by 5. So 1 by 0.2 is 1 by 1 by 5, which is 5 seconds. So after 5 seconds, it's going to stop. After 5 seconds, it's just going to stop. Yes, Dilip, the answer is 5. Perfect. You guys are getting the hang of it. Kudos and give yourself a like by smashing that like button down there. Very good, guys. Amazing. That's how you solve this question. Let's go to the next question on your screen. Okay, let's go to the next question. Now that next question will be, yes, something like this. Friction on some surfaces with some pulley and all of that. So we'll solve these kind of questions where, you might have a block and maybe some pulley and something which is hanging, or maybe another block, something like this, some pulley over here, something is hanging. Okay, so where you have inclined surfaces basically, or flat surfaces, any kind of surfaces, how to solve these kind of questions. Let's start doing one by one. Starting off with one of the questions like this. Imagine we take up a surface here, okay, like this, and this is our pulley, okay, and that thread is wrapped on it like this, and there are two blocks. One block is here, another block is here. This particular block is of mass 2m. This is m. Okay. And there is some friction which is over here. That mu is example 0.5. That mu is basically 0.5. Question is, you release it, it will accelerate. Question is, figure out the acceleration. Find the acceleration of the blocks. That's the question. Simple, straightforward. Can you figure out what's the acceleration of the blocks? Okay, let's do this, my dear warriors. Okay, VCare adventure. I mean, if you open the website or app from your Vedantu account, you will see VCare or some contact or something, support will be there. Call us, support, get in touch, Sam, something will be there. Click on that. Or if you want to write to me on Telegram, Captain_Shreyas or Captain Shreyas, search for it on Telegram. One account is there. Okay. Hi, Ananti, welcome. Okay. Yes, I'm waiting for the pulley also. Okay. Now here I'll tell you, pulley has not much role. I mean, it's just changing the direction of tension. So we are not considering friction in the pulley and the thread. It's the friction which is only there over here, not anywhere else. Okay. Great. Fine, sir. Now what to do next? So everybody, what else to do? Nothing else. I mean, that's what we always do, right? Drawing the free body diagram. Okay. So M's FBD here and that 2M's FBD over here. So this is your M. This is your 2M. What are the different forces acting on them? 2M's weight, tension on the top. M's weight, normal like this, right? M's weight will be down and normal will be like this. Of course, there is one tension which will pull this mass like this. But remember, because it will begin to move, the friction will act here and it will act against the motion. So there will be a friction also. So let's start marking them. This is mg, this is your normal, this is your tension, this is your kinetic friction. There is 2m into g, and of course there is tension. And we should definitely not forget the acceleration, the effect. This 2m will come down, this mass will go exactly the same amount by an acceleration of a. This will come down, this will go right. If this moves 5 meters, this will move 5 meters. This moves x, this will move x. This goes a, this goes a. Same acceleration in magnitude. Okay. That's it. Nothing else we have forgotten. Everybody confirm. Give me a thumbs up quickly. Okay. Right. Awesome. A to Z, Kalyani. Shortcuts. What do you mean by shortcuts? Is there like a PDF, is it? I don't know of any such PDF given by any such teacher. And if they have given, they have fooled you nicely. Okay, there is nothing like a shortcut for JEE. If they have given you a shortcut, your marks will also be shortcut with negative. No shortcut for success, no shortcut for physics, no shortcut. Yes, there are tricks in the problems which you will learn, but it will not be applicable every single time. Okay, so you need to know when to use a trick, when not to use a trick, how to solve a problem. Okay, yeah, Few tricks are there, but you cannot make a list, or only these tricks are there. One PDF is there, you solve this PDF or you understand this PDF, full sir, full marks. My marks increased by 50 marks. Some teacher made that PDF, he has fooled you. Okay, don't go by that. These are all tricks for views, and we do not do anything for views on the channel. We are just focused on your improvement, your rank, and your selection. And that's the reason why students come back to this channel and they genuinely write, you know, sir, I got into IIT, I got into NIT just from your YouTube videos, your batches, and everything. That's simple. Okay, it's not about some channel will get some crazy views because of some news, this, that. No, straight to the point. Give quality content. Yeah. So talking about this problem. Acceleration is down, so any force down will be positive like 2 mg, but any force which opposes the acceleration like the tension will be negative, will be the total mass 2m multiplied by a. That's Newton's law, nothing else. Here acceleration and tension same direction, so tension is positive, friction opposes it, so negative, the mass which is m multiplied by a. Obviously we have to solve it by getting rid of t. So if you add both these equations, if you add both these equations, t will get cancelled and you will get 2 mg minus fk will be ma plus 2 ma. Just got this, guys? Why the tension over here and plus t over here just got cancelled? Okay, perfect. So now let's solve this further. 2 mg minus fk. Fk is mu into n. Mu is given 0.5. Normal. Guys, can you quickly guess how much is normal? Normal will be just equal to mg in this case. So just put mg. Ma plus 2ma is nothing but 3ma. Okay. 2 mg minus 0.5 mg is 1.5 mg is equal to 3ma. mm cancels. Therefore, A will be equal to 1.5 g divided by 3. Now 1.5 by 3 is 1 by 2. G is nothing but 10. 10 by 2 is 5. So 5 meters per second square is the answer. What a wonderful question. We got it. So whether you have surfaces, blocks, pulleys, planes, etc., that's it. Done. Sorted. Is that clear? No, not 3 Dilip. It is 5 meters per second square. I think you made a mistake. Yeah, since the same is rope, you took tension due to the block and 2m. Okay, same. Yes, it's the same rope. Remember, in the previous session I have given, if the rope is same, tension is same. It will not change. Okay. So for a singular rope, the tension in that entire rope everywhere is same. Yes, Nehal, ask the doubt, whatever it is, related to this question. So for this block, we drew free body diagram, solved it in y direction. For this block, in y there is nothing happening. In fact, mg is equal to n. Horizontally, tension minus this force is the unbalance. That unbalance is mass into acceleration. Yeah, 5 meters per second square. Perfect. Let's go to the next question coming up on your screen. Here it comes. Here it comes. Imagine now we give you an inclined plane. Okay, an inclined plane is there. An inclined plane is there, and let's say there is a pulley like so. Ayo. Let's say this is having a mass of m over here. Let's say this is having a mass of maybe 5 times of m over here, and let us just say that this particular inclination over here, okay, that is 37 degrees. Okay, that is 37 degrees. Okay, that is given to you. Maybe this mass is actually not given to you. Let's assume that. In fact, this mass, capital M, we have to find so that, observe carefully, this system, this block accelerates like this. accelerates like this with some acceleration of maybe 2 meters per second square. We have to figure out how much should this mass be so that this block accelerates up with 2 meters per second square. Okay, no problem, Dilip. Happens, silly mistakes. Clear, Nehal. Oh, amazing. Glad the doubts got cleared. Hi, Smiley Ocean. Okay, let's do this question coming up on your screen. Obviously, we have to draw the free body diagrams, no other option. Starting off with the free body diagram of, I think, 5m, because something is given for 5m. So maybe I will solve for 5m first. Okay, it's like this. And whenever you have inclined planes, I have told you this, always, do this method. You draw the inclined plane, you also show the perpendicular to it, and you also draw the vertical and of course the horizontal. So divide it into 8 parts, things start looking easier. As you can see, the inclination is 37. That means this is 37. You can leave apart, every alternate will be 37, like this one will be 37, even this one will be 37, this one will be 37, like that. Okay, now let's draw the forces. Normal force, of course, like this, it has to be perpendicular to the surface. So normal is like this. Tension force will be here. It will pull that block here. So I'll put tension also here. Since it is moving up, friction will act down, always opposes the relative motion. So kinetic friction will be here. Mg will be down, which I have to split it up. Yeah, the mg weight force will be down like this. Do not forget. Yeah, mg will be like this. I'll split it up, obviously not needed like that. So one component will be like this and the other component will be like this. If you ask me how much are these components, this is closer to 37. So this will be mg cos 37. Oh, but wait a minute, the mass is actually 5 mg. Let's not forget that. Okay, so weight will be technically 5 mg. So this will be 5 mg cos 37. Now cos 37 is 4 by 5, 5 cancels. So it will become 4 times of mg. Same way, this one will become 5 mg sine 37. Sine 37 is 3 by 5, 5 cancels. So it will become 3 mg. Is that clear? Why it is 3 mg, why it is 4 mg? This Fk, I do not know yet. Normal, tension, that's all. And last thing, the acceleration is not a force, so show it off it. So 2 meters per second square. So if you look at the inclined plane, there is acceleration because tension is more than the friction and the weight component. So if you ask me, along the inclined plane, the tension is more, that's why it is accelerating, and it is balancing friction as well as that 3 mg, which is that component. So that will give me the mass into acceleration, which is 2. I'm just using net force is mass into acceleration. Just using net force is mass multiplied by acceleration. That's all. This is the net force. This is mass into acceleration. Okay, I do not know tension, but do I know friction? I think so. How do I know friction? Friction is mu into n. Oh, I think mu was missing. My bad. I think I did not give the value of mu. So sorry, guys. Mu was needed. So let's say the value of mu is maybe 0.2 or something. Okay, Chuma, I'm taking some random value. Mu is basically 0.2 or something. So this Fk will be mu which is 0.2 into the normal. Oh, great. So let's find out Fk separately then. Let's find out Fk separately because a lot of calculations will be there. It will look very confusing. So if you ask me Fk is mu k into n. Mu k is 0.2. How much do you think is the normal force? Normal will balance the component of this weight. So it will be basically 4 mg. It will be basically 4 mg. Okay. So Fk will be, oh, yes, 4 mg, perfect. 0.2 into 4 is 0.8. So 0.8 times of mg. So this will be 0.8 times of mg. Is that fine? Everybody with me on this? Yes, perfect. So 0.8 means 4 by 5 times of mg. Okay, so that is Fk. So let's use that over here, which is 4 by 5 times of mg. And of course, this minus 3 mg is there. And this will just become 10 times of m. That's it. Okay. We should also, I think at this point of time, substitute the value of g. The value of g is 10. So I think it's better to do that. So m into g is basically 10 minus 3 times m multiplied by g, which is 10. 5 into 2 is also 10 times of m. Okay, let's see what exactly happens. This over here, 5 and 10 cancels 2. 2 into 4, 8. So minus 8m minus 30m is equal to 10m. So therefore, P will be equal to, just check that out over here. These things will go on that side. 30 and 8, 38. 38 plus 10, 48. So this will become 48 times of m. Okay, so this is the value of tension, 48 into the mass. Okay, whatever numerical value it comes out. But it's not the end of the story. Yes. Yep. Yes, Nihal, yeah, that is fine, even if you did not convert the decimal. But in the end, maybe looking at the options, you can accordingly convert or not convert. Okay. I'm just converting it into fractions because I think it looks easier then. Now, like I said, we have to figure out what is this mass. So, time to start drawing the free body diagram of that mass over here. What are the different forces acting on it? Its own weight is pulling it down by mg. The tension is pulling it up by t, and it is going down eventually with an acceleration of same value, 2 meters per second square. So if you again apply Newton's law over here, bigger force minus smaller force is mass into A. This is big because it is going down. So mg minus t is mass multiplied by A. Okay, g value 10. Perfect. Tension value 48 m. So 48 times of small m is equal to 2 times of m. Okay, I think it's best to move this 2m over here. 10m minus 2m is basically 8 times of capital M is 48 times of small m. What do I want? I want capital M, right? So capital M is 48 by 8. Come on, my dear students. Yes, it is 6. So 6 times of small m is the answer. So this mass should be 6 times more, and or 6m basically than small m. Yes, perfect, Dilip. You got the answer as 6m. Perfect. Oh, amazing. Oh, kudos to all of you. This is how you solve the problems on friction. At the end of the day, it's just FBD and realizing whether it is FK or FS. I have a feeling I need to give you guys a killer question. Okay? I need to give you guys a killer question. Without that, I won't be getting a good night's sleep. And this was asked in JEE advanced maybe some 30-40 years back. Are you ready for the challenge? Show me some fire in the chat box. Are you ready for the challenge? Yeah. The problem is find the minimum force after which a block of mass m moves on a horizontal surface whose coefficient of friction is mu. That's it. That's the question. Find the minimum force after which a block which is kept on a horizontal surface moves. Okay. So let's think, visualize what is exactly the question. It's a JEE advanced question 30-40 years back. It has also got repeated in different ways in some of the JEE mains or even some JEE advanced as a small part of a bigger problem as well. So this is our block and this is our surface, horizontal. Okay, moves on a horizontal surface. The block's mass is also given to me. Perfecto. But what is the problem then? The question is to figure out the force. Then I think like you will be like, isn't it like straightforward? I mean, I pull it, exactly how much is the friction, and I know there is normal and there is weight. Normal will be weight and friction will be balanced by my pull force. So shouldn't it be more than mu mg? Mu n, which is mu mg, isn't it? Yeah, pseudo force is used, but right now, Nihal, we have not yet gone into the pseudo force domain that I have to teach. One day is just dedicated for pseudo force, non-inertial frames, not today. Oh, sorry. That is not the answer you are telling me. Yeah, it will be there in the options, but it will give you -1 marks. Oh, so we need to be careful. And when such simple statement based questions come, or some simple looking question comes, you should be extra careful because there always is an weight. G plus A, what the hell is A? I don't know what is A. Okay. Now, my real question is read the question. Find the minimum force. Did they really tell you the force is like this? Anywhere in the question? You just assumed it. Oh. So what, sir? Obviously, you will pull it like this, no? I have a question for you. If I ask you to pull a box with minimum effort, will you pull it horizontally or will you pull it at an angle? Even your brain knows this by experience. I think you'll pull it at an angle. It is easier. Reason, when you pull it at an angle, you lift it partially, the normal reduces, the friction reduces, makes it easier to pull. Oh, in fact, nowhere has it been mentioned the force is horizontal. So you just randomly assumed it, which is wrong. I want the force to be minimum. So, I will just take the force like this and I will just assume this force maybe like this. This is my force at an angle. And of course, I have my normal force here like this and my weight force like this. And friction will opposite like this, of course. So normal is there, weight is there, and static friction is there. So force might be actually at an angle. That is the catch of this problem. And let's assume that particular angle which I have shown over here, okay, that angle which I have shown over here to be theta. Oh, the force could be at an angle which might help the normal a little bit in easing it, which might make it easier for me to pull it. Sir, but at what angle? You didn't give the angle, sir. Oh, even if you maximum force, though, you can apply any maximum. It will anyways move. If you apply maximum force, though, it will move. The problem is, with the least effort, can you move it? With maximum, I can bring an elephant, it will move. But can I bring a frog and make it move? That's the question. Okay? I have little effort. Sir, take 45 degrees. Like, where did you come from, man? 45 degrees? Sir, maximum range. I've seen everything in life 45 degrees. Ayo, no, bro. It is not like that. Everything in life is not 45 degrees. Sir, more angles, sir, 90 degrees. Sir, 0 degrees, sir, 30, sir, 60. I'm like, where do you come from? Are you coming from school or what? Because in school, you learn all these things. Beautiful angles, beautiful answers, everything in the margins, underlined, highlighted. That's how board makes you think. That's not the case in this situation. You have to think a little bit differently. Think what happens if this force is more. This theta is more. If theta is more, it's more like I'm lifting it than pulling it. Oh, I will not be able to pull it then so much. If this angle is less, then I'm pulling it, but I'm not lifting it so much. I want to lift it so that it is easier on me. The interlocking will reduce. But if I make the angle too much, then I'm not pulling it enough. So there has to be a balance. We need to find a compromise. We need to see where, the effect is getting neutralized, where I'm able to pull it with the enough force, but I'm also lifting it simultaneously. It's like you have to weigh both the options. Yeah. If you push it, then what happens if you push it? Then a component will push it down. It will add to the weight and normal will increase. If normal increases, friction will increase. which will make it even more difficult. That's why you should never push a furniture. You should always pull a furniture, which eases the normal. That is the concept here. Is that making sense? Yeah. Sir, where can we write the mock test? Mutunri, you can write the mock test in the Sigma batch. We have regular test series, class tests. So that's the best thing that you can do. Amazing test. Plus, we have access to pedagogy within the Sigma Express batch, where you can generate your own mock tests on any topic, on any from any book or any type, like PYQ test or a mock test on whatever questions you made wrong or whatever questions you left, whatever questions you did, all that. You can choose the nature of the test, everything. So self-created test assignments are there. Plus, you have your regular mock test, and in the end, once the portions are done, we start with the revision part tests and full tests and half tests, and then we go to all India level tests. Okay, so that's there in the Sigma Express. So initially, will it lift up? It's not lifting up like permanently. If it lifts up, then it will be in air, then it is gone. Like, I mean, there is nothing to pull. Then though it is easy. You like, if you do, it will start moving. So I don't want to lift it off. I don't want it to break contact. Then it is meaningless. I just wanted to relieve its normal. Like, imagine you're standing and somebody pulls you up. Then if you're standing on a weighing machine, the reading will go down, right? It will not become zero. It will just easen up the force on the ground, on the surface. You're not completely off the ground. Your feet are still touching, but it's just that somebody lifted you, or you are doing pull-ups, or you have a bar and you're pushing it down. You just feel less pressure and it's easier to slide then. Making sense now, everyone? All right, perfecto. So now that we understand it, let's figure out the components, resolve the forces, and maybe we'll get something. There is a component here, and of course there is a component here, and this particular component is F sine of theta, and this is F cos of theta. So if you ask me in the y direction, okay, if you ask me in the y direction, normal is also there, and F sine theta is also there. Mg is down, so that will balance Mg. From this, I can figure out normal, which is Mg minus F sine theta. Okay, amazing. What about the x direction, sir? What about the x direction, sir? So the x direction, you will notice there is only F cos theta, which is balanced by Fs. But if I want the force to be just enough to pull it, this Fs will then become Fs max. It is the limiting friction. So this will become limiting friction. It is just on the verge of sliding. It is on the verge of slipping or sliding. So it is Fs max, which means it is mu into the normal. But wait a minute, I already know the value of normal. The normal is this, which is mg minus f sine theta. Okay, f terms, let's bring it together. So f cos theta, this is minus mu f sine theta. So it will become plus mu f sine theta. Only thing left on the right hand side is mu mg. So taking f common, okay, just take the value of f common. What do I get? Just check this out. On the right hand side, we have mu times of mg, and below, what do we have? Cos plus mu sine. Cos theta plus mu sine theta. Oh my hell Lord, what did we just get? Crazy. We got some function now. But theta, God only knows. Now it's a optimization question. Every theta gives me a value of f. Every theta is giving me a value of f. I want to know the value of theta for which it is minimum. That is one way, which means maxima minima. It's going to be hell longer. But acceleration not needed, because I just want it to move. Minimum effort to just move, to just moving. Acceleration there. So just moving, barely moving. Yeah, so no acceleration. Got it? Okay. Sir, it's a hell lot of a problem, sir. Maxima, minima, I don't like it. Derivatives and all of that. That too in the denominator with trigonometric functions. Okay, what do we do? Think logically. If my force has to be minimum, then this denominator has to be, come on, answer it in the chat box. Yeah, loving it, Dilip, amazing. Yes, it has to be maximum. Oh, fine, sir. You made it little easy, but still, how the hell do I make this maximum? Bro, there is there is one trick in mathematics. It says a sine theta plus b sine theta's maximum value, is root of a square plus b square, and the minimum value is minus of root a square plus b square. Oh, is that so? Maximum, minimum values. This is standard in trigonometry. You learn that in case you have not learned it yet. Maybe Namrata ma'am would have taught you in trigonometry. How many of you remember it? Yeah. Oh, sir. So we want this to be maximum. Huh? So I already know the maximum value now. Yes. And what is A and what is B also, it's very clear. So one single step we get the answer. So it will be mu mg, and maximum value of this will be root a square plus b square. A is 1, as you can notice. A is 1, b is mu. So technically speaking, 1 square is 1 only, no? So chumma, I put one extra step to make you understand. So that's it, 1 plus mu square. That is the final answer. Done, dusted. If you know the mathematical part, it becomes easy. Else you will waste your time in mathematics of derivatives and maxima minima. So that's how things are to be done in a smart way. This is what a trick is. Somebody was asking, sir, can you give me a PDF of tricks? Tell me, how do I put this in PDF? And even if I give you this trick in PDF, how will you even apply it unless you have solved this kind of a question? So that's why always believe in the process, go through the process, and that is exactly what I do, because I have trained all India ranks, 2 digits, 1 digit, everything. Okay, so I know what it takes. Perfecto, amazing go. Let's go, sir. On the next concept of angle of repose. What the hell is this? Angle of repose. Angle of repose. What the hell is this concept? Okay. See, boss, simple, I will tell you. Okay. Inclined surface inclination keeps increasing. At one point, the block will slip. Imagine this block right now is at rest, still at rest. Now it is on the verge of slipping, and here it actually slips or skids. Then that particular angle at which it is on the verge of slipping, that angle alpha is called as the angle of repose. It is called angle of repose. And before that, whatever angle was there, it could be less, it could be more, that's okay. That critical angle is called alpha, which is angle of repose. So if theta is less than or equal to alpha, then it doesn't slide. It doesn't slide. Doesn't slide. But if the inclination is more than alpha, then it will slide. That is the concept of angle of repose. That is the concept of angle of repose. It's cos theta plus mu sin theta. It doesn't matter, Dilip. I mean, that previous one, no. Here only you can check what is cos, what is multiplied with cos, it is 1. If I write a sin theta plus, oh, sorry. My bad, sir. Oh, yo. What did I put? B cos theta, man. By mistake, I put B sin theta. My bad. Thank you for pointing it out. A sin theta plus B sin theta will be A plus B sin theta. So sorry. A sin theta plus B cos theta. My bad. Okay. So A is over here mu, and B over here is 1. Okay. It's the same thing. Fine. Now clear. Awesome. Anyways, coming back over here. See, if I draw the free body diagram, if I draw the free body diagram exactly at the angle of repose, these are the forces that will be there. Mg will be there only. Mg will be there, but I will have to split it up into two components, one like this and one like this. Obviously, this particular angle that you see will be alpha. So this will be mg cos alpha. This component will be mg sin alpha. There will be also a normal force like this, and of course the friction will try to prevent it, and when it is on the verge of slipping, the friction would have reached its maximum capacity. That's why it is Fs max. So this is when it is on the verge of slipping. If you ask me what is the acceleration, acceleration is still zero because it has not yet slipped. It is on just that limiting condition when it is about to slip. Any more inclination, it will slip. Right now, it is not slipping. Yeah. Class will be beyond 11. I think we are running a little late because I went not slow, I went point to point basics. I know it will go beyond 11, but that's okay, I guess. Okay, fair enough. Sir, now what? Solve the components and you'll get the answer. See guys, normal will be obviously mg cos alpha, and here mg sin alpha will be Fs max, but Fs max is mu into n, but n is mg cos alpha. So this is mg sin alpha, mg cancels. So sin alpha will be mu s cos alpha. Therefore, mu s will be sine of alpha by cos of alpha. Therefore, mu s is tan of the angle of repose. Now, this is a formula which you better remember, guys. Mu s is nothing but tan of alpha. Okay, straight and simple. Let me make you solve a very laddu question on this. Like direct question had also come just some time back. Can you figure out the angle of repose whose surface has a coefficient of friction of, let's say, maybe 0.707? Okay, can you find the angle of repose? Sorry, not 0.707. Let's take it as 0.75. Chumma. Let's see, how do we solve this? Now, we all know the formula goes like this. Tan of alpha is coefficient of static friction. Mu s is 0.75. If you convert it into fraction, it will become 3 by 4. So tan alpha is 3 by 4. Can you guess the angle now? Can you guess the angle? Whose tan is 3 by 4? Quickly answer it in the chat box. Yeah. Whose tan is 3 by 4? Standard 3, 4, 5 triangle. Yes, it is 37 degrees. It is 37 degrees. Simple, straightforward. Also very interesting to see that this block will slide irrespective of what the mass is after this angle. So there is no mass. There is no G also. Meaning that same block, same surface on moon, on Jupiter, on sun or whichever planet, independent of G. So it will always slide exactly at the same angle as long as the surface is same. So very, very important. It is independent. This angle of repose is independent of number one, mass, and number two, acceleration due to gravity. Both it is independent of. There was one killer question which came. Where there is a sand heap is formed with a circular base of 4 meters. If the particles have friction coefficient of mu is equal to point, let's say 8, what's the maximum height of the conical heap of sand which you can form? What's the maximum height of the conical heap of the sand which you can form? Let's understand this question. Very beautiful question, guys. See, imagine you make the heap of sand. The circular base of radius is given. Radius is 4 meters. This is radius. I think I didn't mention the word radius. So sorry. Yeah, radius is given. Okay. Yeah. So imagine the radius is fixed and the height is only this much. This is that heap of sand like this. Versus same radius, but I make the height slightly bigger. But I make the height slightly bigger. Versus same radius, I make the height even bigger. What's the difference in all of them? Why is it that there is a limit till which you can make the height? What happens beyond that height? What happens beyond that height? What is the problem? Think carefully. As the height increases, the sand particles will try to slide down onto each other. They will begin to fall off. Yes, these particles will basically begin to slide over each other. They will slide over each other and they will begin to slide, and it will no longer be there. This will collapse. This structure will collapse. Can you see that? So, essentially, if there is a maximum height till which you can build this structure, then that maximum height will be when this particular angle that you see, should be angle of repose. Because after this angle, the inclination is so much that all the particles begin to slide. How many of you this concept clicked right now? Did you love it? Is it amazing? The more the angle, the more the height, the particles have a tendency to slide. There is no difference between this problem and even this theory concept. This like a particle, this surface is like another particle. The surface will start to slide. Okay, once you cross this angle of repose, it will begin to slide. So more the angle, chances are higher, and after the repose, obviously, it will begin to slide. So this is the maximum height, of course, and this distance is your radius, and we can see that tan of alpha is the maximum height by that fixed radius. So tan of alpha, oh, tan of alpha I know is basically mu s, so that is h max by r. So therefore h max will be mu s. Mu s is 0.8, radius is 4, 8 4s are 32, so 3.2 meters. So you can't build that heap more than 3.2 meters. Anything more, it will begin to slide. You might have seen during construction of some building also, they keep a heap of sand or cement or whatever. Even if you pour more cement, it will slide off. And just looking at the angle of that heap of sand, you can guess the friction coefficient. Reverse calculation is also possible. Loved it? Amazing? Yeah. Hello, M2 please. Welcome aboard. That was angle of repose. Now let's go to block on block kind of questions. So here the only concept is, or the confusing part is, because usually you see the blocks FBD, you overlook what happens below. That's why that confusion happens. But once you understand it is based on Newton's third law, it becomes very straightforward. Okay, it's a beautiful question, isn't it, Rama? Yeah. So the logic is simple. Imagine there is one block. And there is a surface. This is the surface. In the first case, it is at rest. Here also it is at rest. But here it is moving like this. Here it is moving like this. But here what happened? Somebody is pushing it like this. Here somebody is pulling it in this direction. Here it is actually moving that block. The orange one is the table, ground, whatever surface that you want to take. In the first two scenarios, which friction will come? Which kind? And in the third and the fourth scenario, which kind of friction will come? Answer it in the chat box quickly. Yeah, it's at rest. Rest means stationary. That means static friction will come. Here it is in motion, so kinetic friction will come. Yes, sir. Perfect. So if you ask what is the direction of friction on this yellow block, because the tendency is right, so the friction will be on the yellow block this way. Here the tendency is left, so the direction of the friction coefficient, friction value, static friction will be right side. This is the direction of friction. Everybody with me? Here in this case, it's actually moving right, so friction will be here. Here it is actually moving left, so friction will oppose the relative motion. So Fk will be here. This will be also Fk. Okay, sir. Fair enough, sir. Now, if I ask you what friction will act on the lower block or on the lower surface on which it is sliding or about to slide, you will quickly jump and tell me, sir, Newton's third law. Yes, correct. Newton's third law, guys. If this surface on this surface applies a force this way, this surface on this surface will apply a force like this. If orange on yellow applies a force this way, yellow on orange will apply a force like this. Same thing here. Orange applies on yellow left side, yellow applies on orange like this. Orange applies on yellow right, so yellow applies on orange left. So friction on the lower surface will be just found using Newton's third law. Is that making sense to all of you? So all we have done is, if one force is an action force, the other force is basically reaction force. All that we have done is the third Newton's law of motion. The third Newton's law of motion. Yes. Thank you so much, Dilip. Yes. Now, imagine both surfaces are moving. Wow. Both surfaces are moving. Then what happens, sir? Let's understand it. Okay. So, let's say this on the top. And this over here. Okay. I just created duplicate. Yeah, anyways. Okay. Now observe carefully, guys. The yellow one is moving at, the yellow one is moving at 20 meters per second. Here, yellow one is moving at 5 meters per second. Here, it's moving like this at 20 meters per second. Here, it is moving like this at 5 meters per second. Okay. Similarly, here it is moving at 10, or let's say 12 meters per second. Here this is moving at 25 meters per second. Here this is moving at 10 meters per second. And here this is moving like this at 20 meters per second. I've taken some different scenarios. I want to figure out what is the direction of friction. Block on block questions, guys. That's it at the end of the day. Let's do this. Ready for it? Yeah. So, Ryan, in the previous section, I just mentioned that if the lower surface on the upper surface applies a force of friction in one direction, the upper surface on the lower surface will apply exactly equal and opposite direction of force as per Newton's third law. So as long as you know any one of this, you can find the other. If I know the force of friction on the upper block, I can find the force of friction on the lower block. If I know the force of friction on the lower block, I know the exact reaction on the upper block. You need to know any one of that pair because the exact opposite will be the second one. Is that okay, Ryan? Perfect. Yeah, now we should take relative. Now you tell me, you sit on the lower block, I mean, it's easier. With respect to the lower block, with respect to the lower block, tell me what is that upper block doing? It is moving with a relative speed of 20 minus 12. Sir, how did you calculate it 20 minus 12 so fast, sir? I have given that trick in relative motion. I said, if you are going in the same direction, same means equal to. How is the symbol of equal to like? Like this. Equal to symbol, right? You join them, what does it look like? Minus. Oh, so that's why 20 minus 12, which is 8 meters per second relative motion. And what does kinetic friction do? It opposes relative motion. So that means on that yellow block, the friction will be like this. So the reaction on the lower block will be like this. Does that make sense? How easy it is to calculate very quickly just by looking at relative motion. That's why that chapter is very important. Yes. Let's do the second one. 5 and 25. Oh, the lower one is faster, guys. The lower one is faster. So if you take the frame of reference of the lower block, lower one is faster, the upper one is slower. So it will appear to move back. It will appear to move backwards like this. Yeah. And if you see the relative speed, same direction means equal to symbol. Collapse the symbol, it looks like minus. So 25 minus 5 is 20 meters per second relative motion. But kinetic friction always opposes the relative motion. So on this, the friction is this way. The reaction of that on the lower block will be like this. Very straightforward. Very straightforward. Okay. Let's do this question. Again, take the lower block as the frame of reference. It becomes very easy, guys. Take the lower block as the frame of reference. It will become easy. Okay. First scenario, this block going in the opposite direction. Opposite means the symbol is cross. But if you rotate the cross symbol, it looks like a plus. So 20 plus 10 is 30. So the upper block will go like this with a speed of 30 meters per second. It will go relative to the lower block, it will go like that. Makes sense. Here, I am going at 20, I am moving faster than the upper one. If I go fast, the upper block will go behind for me. It will go behind for me like this. Same direction, same is like minus. So 20 minus 5 is 15 meters per second relative. Very straightforward now. Friction opposes relative motion. Relative is here. So friction will be like this. Relative motion is right. Friction will oppose like this. Last one. Take the reaction. So this will be Fk. And of course, this will be Fk. Is that making sense, everyone? Clearo? Perfecto? Amazingo? Understood? Yes or no? How to figure out the direction of friction? Give me a fire emoji or a smiley emoji or a heart emoji or a thumbs up emoji. Understood? Clear, everyone? Yes? Let's see whether then you can do some questions. These are some really tricky questions. Even big teachers have seen they don't solve this. Assume the entire system is at rest. Assume the entire system is at rest. And I am pulling this. I am pulling this. Nothing moves. Second scenario. I am pulling this one. Okay, I am pulling this one. Question is to find out where all friction will act and in which direction. That's all you have to figure out. Question is figure out the directions of the friction. Nothing more, nothing less. That's it. Just figure out the directions of the friction. Okay, let's draw FBD. Simple. Okay, the upper block, the lower block. The upper block is being pulled like this. But remember, it is at rest. Remember, acceleration is 0. It is mentioned. It is none of them are moving. Acceleration is 0. Now, think carefully. There are two rough surfaces. There will be two different frictions. So, think carefully. Here, there are forces in the vertical direction. I agree. Yes, there will be one force normal. There will be one mg and all of that. It's okay. It's vertical. But in horizontal, there is only one guy who can come, and that is friction. So, to oppose the pull, I think the friction will self-adjust itself. So, this is the friction on the upper block. I will just call it F1. This, who is applying? Orange. On whom? Yellow. So, when you pull this, the orange on the yellow will pull it or oppose it like this. So, if you pull the upper block, the orange will pull it back, resist the motion this way. So, in turn, the yellow on the orange will apply a reaction force like this of the same magnitude. F1, F1, action, reaction, action, reaction. Newton's third law. Clearo? Amazing? But that's not all. Look at the lower block. Yes, there is a normal from the top. There is its own mg and there is a normal from below, which I'm okay with. It's all vertical. But if you concentrate in the horizontal direction, this friction is this way. So, to oppose it, there must be another friction which will come from the ground surface like this. This would be friction from the ground surface, F2. If you ask me, sir, where is the reaction on it? The reaction will be on the ground surface. So, if you draw the ground surface, then there will be reaction pair on the ground. That is F2. It will act on the ground because the ground pulls it, resists this way. So, the orange block on the ground will apply force that way. This is the diagram. Amazing, right? This question would have cleared so many misconcepts. Now, this is the best killer question. Many people will get it wrong. Okay, this is more difficult than the previous one, but the answer is much simpler though. Let's see if you can get it. Okay, so the pull is over here. Do not forget that. The pull is on the lower block. Things have changed. Instead of the upper block being pulled, now you are pulling the lower block. Like, so what, sir? So easy it is. Isn't it like, sir, I'm pulling it. So friction will be here. Okay. And on the top, here, sir. And on this, opposite, sir, like this. Many people would have thought like this, right? Correct me if I'm wrong. I'm pulling it like this. So friction here and here will oppose that pull. So friction will be backwards. And on the upper block, action, reaction. So friction will be in the front. There is a flaw in this. And some of you would have realized it by now. That in case this is the real scenario, the upper block has only one force. Who will counterbalance it? No one. So if there is nobody to balance it, nothing is there. Mg normal, nothing is there. Second friction can't come on the same surface. So it should accelerate, which is against the given statement that it is at rest. So if it has to be at rest, there is no other option because A is 0. A is 0. There is no other way that this friction F1 should be also 0, because if at all friction was there, it should accelerate and nothing is there to balance it. So if F1 is 0 on this point or this surface, F1 is 0. Also, there is no surface between them. Here, there is no friction. Even if it is rough, there is no need. But then on the lower block, there is a pull. This friction is not there. So the only force which can come is F2. So there will be a friction over here on the below surface, which will balance the pull. So no force of friction between these two, but there is a force between the ground and the orange block. Isn't it a Fab question, fabulous question. Everybody, wonderful question. Yeah, all right. How about this question, my dear students? Imagine, I tell you, listen, there is this block of mass m and it is kept on another block of mass, example 3m, and let's say there is a surface like this which is given to be smooth, and let's say we have been told that you have to apply a force. Question is, how much is that minimum force needed given that between these two surfaces there is a coefficient of friction mu, there is a coefficient of friction mu which is, let's say, 0.5. How much is that minimum force which is needed so that they begin to slip, they begin to slip relatively, they begin to slip relatively? That is the question. Let's try to do this, my dear students. Let's try to do this. Okay, minimum force needed so that they begin to slip relative to each other. So I'm applying this force. When they are on the verge of slipping, remember this surface is anyway smooth, no friction can come over here, there is only friction between m and 3m. So which kind of friction will come? What is that special name of that friction? What is that special name of the friction, my dear students? If you take the upper block, yes, think carefully, my dear warriors. On that upper block, which kind of friction will come exactly? Yep, it will be maximum limiting friction, and it is going to accelerate as a complete system. Think logically now. Yeah, if you consider the entire system of mass 4m will accelerate because of that force. Sir, what about the friction force? Now the friction is internal, so don't even bother showing it. Yes, internal forces are never shown in the FBD. If you consider the entire system, the force of friction is their internal matter. Don't worry about it. So here, friction is internal force. In the horizontal direction, there is only one force and the whole mass is 4m. It will accelerate. So quickly I got the acceleration as F by 4m. So I already know how much is that acceleration, which is F divided by 4m. If you ask me to draw the free body diagram of m, a weight will come mg, a normal will come like this, and because there is acceleration, there should be a force. So which direction the force will be? Always supporting the acceleration. So the friction on the upper block will be like this. Sir, if you had to draw the FBD of the lower block, how would you draw it? Well, it's straightforward. If you had to draw the FBD of the lower block, then if this friction is here, the reaction will be like this. So F will be like this. Lower block's weight will be 3 mg. From the top, there will be a normal reaction, and from the ground also, normal from the ground will be there. And this will also accelerate by the same value. This is how the FBD of the lower block would have looked like. I don't think I need it. I think I can solve the problem here. Sir, will the force of friction be balanced by something? Not at all. Why? Because it is accelerating. It is unbalanced. That's why it is accelerating. Oh, yeah, correct. So we don't need to balance it. It's perfectly fine. So therefore, my force of friction will be the mass times the acceleration. Sir, what is the acceleration? We just figured it out right over here, F by 4m. So put F by 4m, mm cancels. And, oh, this is friction, isn't it? And this will be in the limiting condition when it is on the verge of slipping. And when we put Fs max, it will be mu multiplied by n. So therefore, mu is 0.5. Normal force is mg. Okay. and mm cancels, and we have F by 4. Interesting. Mass is not given, G is also not given. Now we just put it like that. 4 goes on the other side, so 4 multiplied by 0.5 multiplied by mg is equal to F. Therefore, F is equal to 2 times of mg. So if you apply this force, that's it. After this, it will start slipping. Like 2.01 mg slip. They will start moving relative to each other. 4 mg it will slip. 1.5 mg will not slip. 1 mg also will not slip. Okay, so this is the limiting force till which you can apply so that they move together. Yeah. My coupon code for the Sigma batch, you don't have to apply anything. The links already have it. So if you are going to the Sigma batch, directly go to the link over here. Okay, the batch prices have already. Why is it showing more? Okay, it shouldn't have shown more. One second. Do one thing. Go to the live video which I went today. Where is it? Sigma Express. Go to this and Sigma Express. Click on the first link. What the hell happened? Something is wrong. Okay, everything is fine now. Yes, there you go. 1499 buy full course. Automatically the coupon codes are applied. Okay, so the coupon code is S small h small j capital S small IGID 25. Okay, so use that coupon code and I think you will be sorted. You will get the price as 1499 for the Sigma Express. But if you go for the combo, which is the one you should be going for because the prices are really good, instead of 12,000, you're getting for 6499. 20th August batch start date, pure English batch, right? You save 5,500. Again, same coupon code SHJSIGID25. J is capital, that's all. Okay, so that will give you the access. Perfecto. Amazing. So that was the last question. And I hope you enjoyed the session. Like the video and subscribe to the channel in case you haven't done that yet. And I want a comment from all of you. Did you enjoy the teaching? Did you enjoy the concept? Did you visualize it? Did you learn something? Rather than just, attending a class and feeling that everything is simple, but we solved some really killer questions also today. That was the best part. Thank you so much, guys. This was Captain Shreyas. Hasta la vista.